Today we're going to talk about graphing rational functions. So it says examine the following graphs and determine the equations of all horizontal and vertical asymptotes for each. So if we look at this first graph that we have, we can see we have a horizontal asymptote right here at y equals 2, and we have a vertical asymptote right here at x equals -1. And so it's really important that when you are writing your asymptotes, always make sure you write y equals and x equals. That tells us if it's vertical or horizontal. So over here, looking at this next one, the vertical asymptote, which is right here, looks like it's at x equals 0, and the horizontal asymptote is at y equals -2. Looking at the next one, we have horizontal asymptote at y equals -3, and we have two vertical asymptotes on this one at -1 and +2. So -1 and x equals 2. So we have 2 there. Oops. So now let's go ahead and look at graphing rational functions. So the first thing you want to do is factor the numerator and denominator and simplify. Find any vertical asymptotes or holes and graph. These help you find the domain. Then we're going to find the horizontal or slant asymptotes and graph. Find the Y-intercept. Remember to find that. Set x equal to 0 and solve for y. Find the X intercept by setting y equal to 0 and solving for x. Be careful to watch out for zeros in the numerator that make the denominator 0, because again, we can't have 0 in the denominator. Pick points left and right of the vertical asymptotes and X intercepts to help graph. So the first thing we want to do again is to factor the numerator and denominator and simplify. So here I have a trinomial in my numerator, so we can find factors of -6 that add up to 1, +1, so x plus 3 times x minus 2. And then down here, this is already in factored form. And then, of course, you can see that we can simplify. So it looks like the x, oops, I forgot the minus there. So the x minus 2's cancel out right here. So when we simplify, we end up with -2 times x plus 3 over x plus 1. So that's our simplified answer. So remember, for our domain restrictions, you always want to look at the original function. So if I look here, I know that x plus 1 I set equal to 0, and x minus 2 equal to 0, and that gives me x equals -1, and x is equal to 2. So remember, if we want to figure out whether or not these are vertical asymptotes or holes, we plug them into our simplified answer. If we get a number, then we know it's going to be a hole. If we get undefined, then we know it's a vertical asymptote. So if I plug in -1 into my equation, I have 2 times -1 plus 3 over -1 plus 1. So notice that right away I can see I get 0 in the denominator. So this would be -2 times 2, which is -4 in the numerator, over -1 plus 1 is 0, so that is undefined. So that tells me that this is a vertical asymptote at x equals -1. So then the next thing I want to do is try the next value. So I have f of 2. So if I plug in 2 into the equation, 2 plus 3 over 2 plus 1, I end up getting, so 3 plus 2 is 5 times -2 is -10 over 2 plus 1, which is 3, so -10/3. That tells me because I get a value, it didn't make my denominator 0, I know this is going to be a hole. So we have a hole at 2, -10/3, which is about -3.3. We always want to write the exact value for when we're writing the hole. And then now that I know the vertical asymptotes versus holes, I can go ahead and put this on my graph. So we have a vertical asymptote at x equals -1. So I can go ahead and graph that. And I know that I have a hole at 2, negative 1, 2, 3, so negative 10 thirds is negative 3.3, so somewhere about there. Now I want to figure out my horizontal asymptotes. Remember, you look at the degree of the numerator and the degree of the denominator to do this. So the degree, remember, you always want to look at it in standard form. So usually I'm going to use the original problem. I don't want to use the factored one. So if I were to put this in standard form by distributing that negative 2, I would get negative 2x squared for my highest term value, which means that the numerator is a degree of 2 over. And in my denominator, I have to think about foiling this out because, again, this is not in standard form. So if I were to FOIL this, I would get x times x, which is x squared. So that means the denominator is also degree 2. So remember, we said when the degree of the numerator and the denominator are the same, so the numerator degree equals denominator degree, you look at the ratio of the leading coefficients. So your horizontal asymptote would be y equals the leading coefficient of my numerator is negative 2. In my denominator, if I would multiply this out, I would get 1x squared, so 2 over 1, so negative 2 is my asymptote for the horizontal. So negative 2. So we can go ahead and look at the X intercept. So remember that to find the X intercept, you are going to set y equal to 0 and solve. So in order to do that, I get 0. I'm going to do that down here. So the X intercept, we get 0 is equal to negative 2. I'm going to use my simplified answer because it's usually easier. You could use your original problem, but the simplified one will give you the same um, x-intercept, so I always use that one. So if I plug 0 in for y and solve, well, notice if I multiply by getting rid of the x plus 1 from the denominator, if I multiply both sides by x plus 1, notice 0 times x plus 1 ends up giving you 0. So really, the x-intercepts are the zeros of the numerator as long as they're not the zeros of the denominator. So again, because there is, if I use the original equation and I used the value right here of 2, I know that that can't be an x-intercept because it's a whole. Um, so when I solve this, divide both sides by negative 2, and to get 0 equals x plus 3, so negative 3 is equal to x. So that's my x-intercept, negative 3, 0. And then how do you find the y-intercept? So to find the y-intercept, you are going to plug 0 in for x and solve. So for the y-intercept, it would be equal to negative 2 times 0 plus 3. And again, I use my simplified answer to do this over 0 plus 1. So when I do that, I get y is equal to negative 2 times 3 would give me negative 6 over 1, so negative 6. So we have a y-intercept of 0, negative 6. So I'm going to go ahead and plot those points. We have negative 3, 1, 2, 3, 0, and 0, negative 6. And so I want to go back real quick, and I had mentioned before that the x-intercepts are the zeros in the numerator as long as they're not zeros in the denominator. So, and I said before, I always use the simplified answer, and the reason is because if I use that factored form of the original problem before I simplified, which was this portion right here, so if I multiply both sides by x plus 1 times x minus 2 to get rid of that from the denominator, so that would get rid of that from the denominator. 0 times that is 0, so the zeros in the numerator in this case would be negative 3 and 2. But I can't use 2 because that makes my denominator 0, and we said it was a whole. So keep in mind, that's another way I know that that is not an x-intercept, and plus the whole we said was at 2, negative 10 thirds. So for this, whenever you are graphing, you always want to pick points to the left and right of your vertical asymptote. But you can see that means in the left region, I need to either be up in this upper region or the lower region. On the right side, I would be in the upper region or the lower region. So because of my x-intercepts and my y-intercepts and my whole, I know which region I'm in. So we always just follow along the asymptotes. We don't have to get any other values because we're just drawing the sketch of our graph with these values that we have. And so that would be the sketch of my graph. So the domain is all real numbers except for, of course, the vertical asymptote in the hole. So negative infinity to -1, union -1 to 2, union 2 to infinity would be my domain, because again, remember those were the values that we were concerned with. My end behavior always follows along my horizontal asymptote. So as x gets large in the positive direction, we follow along -2, and same thing in the negative direction. So the end behavior approaches -2. So because we have those points, we didn't actually have to pick test points on the right and the left of the vertical asymptote to graph, which makes it a lot nicer. Now, when you are doing these, do not use your calculator in order to graph, but when you're finished graphing, then you can go ahead and get your calculator out to check. So if I wanted to check this, make sure you use parentheses around everything that's in your numerator versus your denominator. You can see I put double parentheses there, and same thing with the denominator values. Otherwise, you would get a different graph. So I'm just checking my work. So my graph looks similar to the one that I did, and I can see if I hit second trace value, if I plug in 2, notice it doesn't come up with anything. There would be an error there because of the fact that it's a hole in my graph. So it looks like the graph is still going, but there again is a hole. And you can also check your vertical asymptote by looking at your table, and you can see that there's an error at -1. And then of course you could check your horizontal asymptote by hitting the trace button and using the left or right arrow, and you can see as you get larger and larger values of x in the positive direction. So as x approaches infinity, your y values are going towards -2. And same thing if you were to do that in the other direction. So again, only use the calculator to check your work. So again, these are all non-graphing calculator problems. All right, let's go ahead and look at the next one. So for question number 2, same thing. We are going to first go ahead and factor the numerator denominator. We can see that this is the difference of two squares. So that factors into x plus 3 times x minus 3. And in my denominator, that factors into x plus 2 times x minus 2. And so that does not simplify any further. So again, we want to look at what makes my denominator 0 from my original problem in factored form. So x plus 2 equals 0 and x minus 2 equals 0. So x equals -2 and x equals 2 are my areas of concern. If I plug in either -2 or 2, it's going to make my denominator 0 because this doesn't simplify at all. So you can even look real quickly. If I plug in -2 right here, -2 plus 2 is 0. 0 times anything is 0. So I know that that means both of these are vertical asymptotes. And that means we have no holes. So my graph, we're going to go ahead and graph our asymptotes. So we have x equals 2 and -2. Make sure you're using rulers for your graphs at home. And then let's go ahead and look at the horizontal asymptote. So we need to look at the degree in standard form. So this is not technically standard form because we have to distribute that 2. So it would be 2x squared for the numerator, so that's degree 2. And my denominator has a degree of 2 as well. So that means the numerator degree and the denominator degree are the same. So it's the ratio of leading coefficients. So y is equal to 2x squared in my numerator over 1x squared, so y equals 2 would be my horizontal asymptote. So let's go ahead and graph that at 2. And next thing I want to do is find my x and my y-intercept. So let's go ahead and find the x-intercept. So remember, the x-intercept is the zeros in the numerator as long as they're not the zeros in the denominator. So if I look at my numerator, I get 0 is equal to 2 times x plus 3 times x minus 3. Divide both sides by 2, and I just get 0 equals x plus 3 times x minus 3. So that tells me x would be equal to -3 for this first one, and if I set this equal to 0 and solve, I get x equals 3. These are not zeros in my denominator because the only two zeros were -2 and 2, so that means those are both x-intercepts, so -3, 0, and 3, 0. So I can go ahead and plot those. So here is 3, 0, and -3, 0. The y-intercept, we plug 0 in for x and solve. So 2 times 0 plus 3 times 0 minus 3 over 0 plus 2 times 0 minus 2. And so when I do that, I get 2 times 3, which gives me 6. And 6 times negative 3 is negative 18 over 2 times negative 2, which is negative 4. So that reduces into 9 halves. So we have a y-intercept at 0, 9 halves. So if we plot that, we have 0, 1, 2, 3, 4 and a half, which would be right there. And so for this now, I again need to graph this by looking at different sides of my vertical asymptote. So on this left side, we need to figure out if we're up here or down here. Well, because of my x-intercept, I know that I'm in this lower region, so all I have to do is take my graph and follow along my asymptotes. In the middle region, how do I know my graph does not go down, or how do I know it doesn't cross over my asymptote here? Well, the reason I know it's not going to go down is because I don't have any other x-intercepts, right? The only x-intercepts were negative 3, 0, and 3, 0. So that tells me that this middle portion should be going up, so it's going to look like a parabola shape because it has to follow those asymptotes. And on the right side of this asymptote, we know we're in this lower region because of this 0, so I would follow along these asymptotes. Oops, I should have made that a little closer. Get as close as you can to your asymptotes without touching or crossing over. So your domain for this would be all real numbers except for, of course, your vertical asymptote. So negative infinity to negative 2 union, negative 2 to 2, union 2 to infinity. And of course, you want to include the union symbol, you can. I won't mark off if you don't. And your end behavior, of course, follows your horizontal asymptote. So as x gets large in the positive direction, you're following 2, and same thing in the negative direction. So 2 and 2 here. And of course, now that we're done graphing this without our calculator, if you want to check using your calculator, you can. Just make sure that if you do check using your calculator, that you are making sure to plug it correctly into your y equals. So I used parentheses around what's my numerator denominator, and I can go ahead and hit graph. So if I hit graph, you can see that we have the middle portion here and the other two sides, which hit at x-intercepts at negative 3 and 3. If I do second trace value 0 for the y-intercept, you can see it has a y value of 4.5 or 9 halves. And so that's a good way to check your work. Again, make sure to do without your graphing calculator first by hand. Looking at the next one, so same thing, first thing we're going to do is go ahead and factor the denominator because the numerator doesn't have any factoring. So this would be x minus 2 times x plus 1. That does not simplify at all, so that would be my simplified answer. What makes my denominator 0 is what we need to look at first. So x minus 2 equals 0 and x plus 1 equals 0. So we get x equals 2 and x equals 1. Because this didn't simplify, I know if I plug in 2 or 1, it's going to make my denominator 0. So that tells me these are both the vertical asymptotes at 2 and 1, and there are no holes. So I'm going to go ahead and graph that using my ruler. So we have asymptotes at, oops, and that should have been negative 1. Negative 1, sorry about that. And so we have negative 1 and positive 2. And I can write my domain now, or I can do it later like I've been doing. So the domain would be all real numbers except for 2 and negative 1. So negative infinity to negative 1 union, negative 1 to 2 union, 2 to infinity. And again, we always write that in order from least to greatest following your number line. Then the horizontal asymptote, you look at the degree of the numerator versus degree of the denominator in standard form. So the degree of the numerator, that's x to the first power. So that would be degree 1 over a degree of 2, because this has the highest power. So when the numerator degree is less than denominator degree, then remember we said the horizontal asymptote was at y equals 0. So I can again go ahead and take my ruler to plot that. And now I'm going to go ahead and find my x-intercept and my y-intercepts. So the x-intercept is a zeros numerator as long as they're not zeros denominator. So in this case we have x equals 0 because there's only one x in my numerator, so that means the x-intercept is at 0, 0, which means the y-intercept is easy to find because if you have x-intercept 0, 0, that's also your y-intercept. But if you need to check, you can always plug that value in. So y would be equal to 0 over 0 squared minus 0 minus 2, so 0 over negative 2. Negative 2 is in our denominator, not 0, so that's why that's okay to write 0. 0 in the numerator is okay, just not in the denominator. Or you can use the factored form. Usually I use the factored form, but in this case, the non-factored form is a lot simpler to write it. So that means the end behavior is going to be approaching 0. So for this one's a little bit different because notice that we have a point on our horizontal asymptote. Well, Miss Thorne, I thought you said that, the asymptote was line the graph approaches but doesn't cross or touch over. That is true for the vertical asymptotes. You can never ever cross over a vertical one, but horizontal asymptotes are talking about the end behavior, what's happening at the ends of my graph. And so sometimes you do cross over them, and if you do, you would get something like this where it's on the axis and it would cross over there, and you'll know because you'll do your x-intercepts. And so if that happens, that means you need to test both sides of this to know where your graph is. And then if you look at this graph, well, another hard part is that we don't know on this region to the left of this vertical asymptote where the graph is. Is it in the upper region, lower region? We don't know the middle, and we don't know this side. So that's when you have to pick points to the left and right of the vertical asymptote to test. So we're going to use a test point sign line to help us. So we're concerned with what happens to the left and right of the vertical asymptote, -1, where it crosses over a horizontal asymptote, 0, and the x value of 2. So we're going to test to the left and right of -1, 0, and 2. So you're just going to actually pick points and plug them in, which I'll do over here. So we're going to plug them into our equation. So the first point that I'm going to look at, something below -1, would be -2. So if I do f of -2, and I can use my simplified answer, which isn't changed from the original one, but we're just going to use the factored form. So I get -2 over -2 minus 2 times -2 plus 1. So that is -2 over -4 times -1, which gives us -2 over 4, which is -1/2. So we know that that point then is at -2 comma -1/2. So I can actually plot that if I want to. So -1, 2, -1/2 is here. But really I'm only concerned with the signs because remember we're just kind of drawing the sketch of the branches for these. So I know this is in the negative region on this side of my sign line. So since we're in the negative region, that means that this part of my graph would be down here following my asymptotes. So now that I know it's in the negative region, I just follow my asymptotes. So if you weren't really to plot that point and just draw close to the asymptotes, that would be fine. So then what's happening now in between -1 and 0? So in between -1 and 0 would be -1/2 or -0.5. So let's go ahead and look at that. So -0.5 divided by -0.5 minus 2 times -0.5 plus 1. So that gives me -0.5 over -2.5 times 0.5. So if you don't know how to do this without your calculator, that's okay, because really we're just concerned about the signs. So if you just look at the signs, we have a negative over a negative times a positive value. So negative divided by a negative means that this is going to be positive. So I know that this one is going to go in the positive direction. Or if you were to actually compute this out, you would get -0.4. So that tells me the point is at -0.5 comma -0.4. But again, it doesn't really matter because what that point is, I'm only really concerned with where my graph is going to go. Is it going up or down? Because it was a positive value, I know it's going to go up. So in this part, it goes up towards this asymptote here. Now I need to figure out, are we going to go up and make a U shape, or is this going to go down more like a cubic graph? And so now I need to test in between 0 and So in between 0 and 2, I can do 1. So f of 1, if I plug that in, I would get 1 over 1 minus 2 times 1 plus 1. And so that gives me 1 over negative 1 times 2, which is negative 1 half. So the point would be 1 negative 1 half. Oops. And again, I don't really care about that value because I just need to figure out what the sign is. So the sign's telling me it's going to be in the negative region. So I know that's at 1 negative 1 half. So if you want to plot the point, you can, or you know that your graph is going to go down towards negative infinity at that asymptote. Then the next part I need to figure out is what is happening to the right of this vertical asymptote. So to the right of 2 would be a value such as 3. So we're going to do f of 3. And do you have to pick the ones right before and after? No, I could have picked instead maybe 4 or 5. It's just easier to do the ones right after the asymptotes. So if I do that, I get 3 over 3 minus 2 times 3 plus 1, which gives me 3 over 1 times 4, so 3/4. So of course the point would be 3/4. But again, I don't really care about that value. I'm just drawing the graph close to the asymptote, so I care that it's positive, which tells me to be in this upper region. So if I actually plot the point, it'd be somewhere around here. And then again, I would just follow along my asymptotes. So that gives me my graph. So this one was a little bit harder because of the fact we didn't have any X or Y intercepts to tell us where our graph was going to go. We actually had to pick points and look at the sign line. So if you don't actually find the point and you just look at the signs, that's okay. Or if you want to find the actual point and plot it, that's okay too. Whatever is easier for you. So if I were to graph this to look at it, and I didn't talk about this before, but whenever I'm graphing these, you always want to graph the original equation, not the simplified answer, because then you might be missing something like from your graph for the holes. So always put in the original equation, and that way if you factored it incorrectly, that would help you as well. So here's my graph. We're just checking it so you can see from my graph it crossed over that horizontal asymptote. We're in the upper region on the right side of this asymptote and the lower region on this side, so that checks out for our graph. And so that is all we're going to do for this, and then tomorrow we're going to take a look at the last two graphs that we have.